Each capacitor shown in figure has a capacitance of 5 microfarad. The EMF of a battery is given as 50 volt. How much charge will flow through AB if switch S is closed? Initially S is open, so let's calculate the charge on each of the capacitor. We have 5 microfarad, 5 microfarad in parallel, so C dash will be equal to, let's say this is the capacitance C1, this capacitance C2, this capacitance C3 will be equal to C1 plus C2. That comes out to be 10 microfarad. Now this C dash is in series with C3, so C equivalent of the circuit will be 1 by C dash plus 1 by C3, that is 1 by 10 plus 1 by 5. It comes out to be 3 by 10, so C equivalent is 10 by 3 microfarad. So Q on each of the capacitor is given by CV, that is 10 by 3 into voltage, that is 50. It comes out to be 500 by 3 microcoulomb. So 500 by 3 coulomb is the charge on capacitor C3 and the resultant of C1 and C2, and this 500 by 3 microcoulomb charge will be divided on C1 and C2 equally. So C1 charge on C1 will be equal to 500 by 3 divided by 2, that is 250 by 3, that is microcoulomb, and that will be the same charge on C2, that is 500 by 3 into 2, that is 250 by 3 microcoulomb. Now please note that the charges, that is 500 by 3, is divided equally on C1 and C2 because the voltage across them is same, and secondly the capacitance is same, and so the charge will same. Now if S2 is short, that is if switch S2 is closed, then capacitance C3 will be of no use because the potential across its plate is same, so charge on C3 is 0. So circuit will be formed as two capacitance in parallel, that is simply attached by a voltage of 50 volt, and this is capacitance C1 and C2. So we have now the charge on each of the capacitor as Q is equal to CV, capacitance is 5 microfarad and potential is 50. So we have 250 microfarad on this and on this microcoulomb. So the total charge will be Q1 plus Q2, that is the Q net, that is 500 microcoulomb. Now earlier charge was 500 by 3 microcoulomb and the final charge is 500 microcoulomb. So the charge that flown after the short circuiting of third capacitor, that is C3, is Q flown, that can be given by Q final minus Q initial, that is 500 minus 500 by 3, which on solving gives 3.33 into 10 to the power minus 4 coulomb. That is the answer.